All right. No. All right. So today we are continuing on with balancing equations. Remember the skills from chapters 5. Well, actually, starting with chapter 4. Chapter 4, 5, 6, and 7 are all kind of cumulative. They build off each other. So you have to know where the elements are on the periodic table. You have to know what the polyatomic ions are. You have to be able to make the right formula from this. And then there's some calculations that we're going to be doing next chapter that go back to what we were doing last chapter. So make sure you're kind of staying on top of it. If not, you need to work on either finding sources from YouTube, like Melissa Maribel, on naming equations, calculating moles, things like that, or going back and reviewing our videos. Today we're going to be predicting products in it. So we're kind of taking half of the equations that we start with, and we're trying to figure out what type. So yesterday we did classification, which should allow us to predict products. So going back to this sheet, I am asking that you turn this in by the end of class today, the sheet that I just handed out. All right. So I just want to kind of go through so that you can make sure that you're on the right track. So this one is asking for moles, and it gives us mass. So if I'm starting with 53 grams of H2SO4, how do I get to moles of this? What's the process? All right, so I need the molar mass. So I'm going to divide by grams, the gram molar mass of H2SO4, and that's out of 1 mole. So remember, to go from mass to moles, we have to know the molar mass. And I'm not solving the molar mass for you. All right, so this one we're starting off with 6 moles of aluminum hydroxide. The first thing we have to know is what is the formula for aluminum hydroxide. So I have aluminum, I have hydroxide. Aluminum will form a +3 charge, hydroxide's a -1. Remember, that -1 is for that whole group, not just oxygen, not just hydrogen. So when this reacts, I get it takes 3 hydroxides to counteract the 1 aluminum. So now, if I have 6 moles of this, and it's wanting to know oxygen atoms, I need to get to oxygen first. So for every 1 mole of AlOH3, how many mole of oxygen do I have? So look at the formula. How many oxygens do I have in aluminum hydroxide? I have 3, because 3 times 1 is 3. So for every 1 mole of aluminum hydroxide, I have 3 moles of oxygen. So essentially I have 18 moles of oxygen. Now, I need to get from mole oxygen to atoms oxygen. How do I do that? What's the relationship I'm going to use there? Avogadro's number. So Avogadro's number tells us for every 1 mole of something, all right. So every one of those steps to get there is in your periodic table reference packet. Avogadro's number is listed there. The polyatomic ions listed there. The charges, you should be able to use the periodic table to get there. These are all skills that we've done over the past few weeks. Next question, it says, write a balanced chemical equation. I'm not so much worried about the phase, except for unless it tells us there. So we start with solid calcium, so I'm going to write Ca with an S. All right. Reacting with aqueous hydrochloric acid, so HCl AQ, to form a solution of calcium chloride. Whenever you see solution, that automatically tells us that it's aqueous. So calcium chloride plus hydrogen gas. Then all you would have to go through after that is balance it. All right. So here's the thing. I can stand up here and give you notes and talk to you until I'm blue in the face, but if you're not going to take the time to learn it on your own and practice it on your own, I can't do it for you. I can't do that part for you. All right. So I can't take the tests for you. All I can do is give you opportunities. Yes. That is an AQ. So anytime you see the word solution, that's automatic. So if you see a word prompt that says solution, it's automatically aqueous, because solution just means it's dissolved in water as well. All right. Now, so these other two, that's stuff that we were doing yesterday as well. We're just going from the word equation to the balanced equation. So you have to be able to look at a name and get there and then balance it. It's balancing equations. Go back, watch the videos. Find a video on balancing equation. It would have been Monday or Tuesday. This week. We just started this week.
Oh, that's why I don't understand. Yeah, I need some
okay.
practice.
All right. So, all right. So again, we are continuing on with balancing equations, but today we're adding a step of predicting products. Today we are only going to be working with single replacement reactions. And I don't know why I call it SSR when it should be SRR, but that's what I just write down for my abbreviation. All right. So we're going to be looking at single replacement reactions. So recall from yesterday. Recall from yesterday that we had different types of reactions. So the types of reactions that we talked about yesterday is we had synthesis, where we had two or more reactants in one product. So remember that a synthesis reaction looks something like A plus B reacts to form AB. So if I gave us a reaction and I said Na plus Cl, and I asked you to predict the product, would you be able to recognize that as a synthesis reaction and know what to do?
Yeah, NaCl2.
There won't be NaCl2. Because remember, sodium makes a +1, chlorine makes a -1. So I can't change the way they react. I can only change the coefficient and the amounts.
Wait, I thought they used to be up.
What type of compound is that? Ionic or covalent?
Ionic.
Don't guess, no. There's a metal and a non-metal. So everybody else included, what type of compound includes a metal and a non-metal? Ionic. So that means that the only way we can get a formula is based off a charge.
So if it was covalent, then we could just put them together.
Well, we would have to know what compound's being formed. Covalent is not going to work this way. Covalent's not going to work that. Covalent's got a different naming system. I tell you what's there. So you have to be able to recognize certain things. It's all about patterns. All right, decomposition. How does decomposition look in relation to synthesis? It's just the opposite. So decomposition is going to have some sort of compound that breaks down into smaller parts. Most of the time, you will not have to predict the products of a decomposition or a synthesis. Most of the time, it's going to give it to you. I don't remember ever being asked to predict the product of a synthesis or decomposition. The only the only ones that they'll ever ask us to predict a product is a single replacement, and I actually did write SRR, is a single replacement. Remember where we have an element by itself plus some compound, and they're going to replace each other and form some new element.
So how do you know which one goes together?
Whether it's a metal or a non-metal.
So
Metal replaces metal, and I'm getting there. I haven't taught that yet.
Oh, okay.
All right. So you're going to have some new thing created where you have a compound and an element. All right. And then for double replacement, kind of the same situation, except for this time we have two compounds. This, you only have one choice. They're just going to trade partners. All right, something like that. All right. Now, we had one other type that I told us about yesterday.
Combustion.
What in combustion, what will always be the product of combustion?
Well, and carbon dioxide.
Yes. So if you ever have a compound that starts off with some variation of C and H, it could have CHO, it could have CHS, it could have CHN, and it reacts with oxygen, and it asks you to predict the product, the products are always going to be carbon dioxide and water. All right. So no matter what, if you see one that has this circumstance in the front, the product is always going to be carbon dioxide and water. Now you will have to go back and balance at the end. They're not balanced when we do this. We're just predicting products at this point. All right. So we're focusing on single replacement or single displacement reactions today. In a single replacement reaction, the lone element will replace the element in the compound that has the same ionic charge. So, if the element by itself is going to replace the element that has the same type of ionic charge, what type of compounds do you think we're going to be dealing with in single replacement reactions? What type of compounds do you think we will be dealing with in the metal and non-metal, which is ionic? Thank you. All right, so we're only dealing with ionics in this. And so when I say same charge, I mean a positive can only replace a positive. So a cation can only replace a cation. An anion can only replace an anion. All right. So if I have a scenario where I'm trying to see if a reaction between zinc and hydrochloric acid will happen. When we look up zinc on the periodic table, we find out zinc is a metal. What type of ion do metals normally have? Positives or negatives? Positive. So zinc's going to form a positive ion. And then when we look at HCl, what type of ion is H going to form? Typically. Look at where it's located on the periodic table, a +1. So it's going to typically have a positive ion. Now, I don't want to leave chlorine out on this, but we know chlorine's a nonmetal. Chlorine's going to make a negative ion. So which two elements will replace each other? Zinc and hydrogen or zinc and chlorine? Zinc and hydrogen. I'm going to switch the metal. I'm going to switch the cation for the cation. All right. Now, different scenario. If I have bromine reacting with HCl, bromine forms what type of ion? Where is it at on the periodic table? It's a nonmetal. It forms a negative ion. So which one is it going to replace, chlorine or hydrogen? Chlorine. So when you're looking at this, a metal can replace another cation. A nonmetal can replace another anion. All right. So my question is, and we don't really know the answer yet, but if I just give you a prompt, will that reaction always occur? No. It depends on the reactivity of the elements that are involved, elements and compounds that are involved. For example, copper will not react in hydrochloric acid. You can pour hydrochloric acid on copper all day long and it will not destroy the copper, but it will destroy other metals or replace other metals. So and it's because copper has a low reactivity in comparison to hydrogen. So no, single replacement reactions will not always occur. Sometimes you can just have two things and they'll sit there and nothing will happen. You can predict SSR or SRR, by studying elements and seeing what they're switching. So in order to know if they switch or not, we need a tool. So take out your periodic table reference packets, and I want you to turn to, let me see if I can find it on here. You gonna tell me it doesn't have it on there? I'm gonna have to give you this one. All right. So I'm gonna need to print this out for tomorrow. All right. So do me a favor, if you have your Chromebook, search activity series and find an image, and it'll look similar to what I pull up in just a minute. So in order to determine if a single replacement reaction will occur and to be able to predict the products, we have to have something to know which element is more reactive than another element, and I cannot believe that they did not put them on here. Wait, let me see something, because I might have been looking at another reference packet. Yeah, that's what you're looking for. No, they changed some things last year. They changed the reference packet, and it wasn't on there. So I'm going to have to make one that has it on there. All right. So if you search up an activity series, you should find something that looks like this. All right. It's not gonna, they're not all going to be exact, but they're going to be close to this. So an activity series tells us the higher you are on the list, the more reactive that particular metal or non-metal is. So when I'm looking at this, and like I said yesterday, sometimes you'll hear me talk about elements in terms of being dateable and things like that, putting a human emotion on it when it's really not. But down here at the bottom of the list, these are the least dateable. The ones at the top of the list are the ones that's always dating, meaning they're always hooking up. All right. So the higher the single element is on the list, the more likely it is to react. So that's why these are the most reactive. These are the least reactive. So for today, I just want you to pull up a activity series, keep it handy. We're going to use it, but I'm going to give you a copy of it for tomorrow. For tomorrow, for when we're doing these. All right. So looking at our example, zinc plus hydrogen chloride. Zinc is the element by itself. Hydrogen is the element in the compound. So in order for this reaction to occur, zinc has to be higher on the list than hydrogen. So on my list and on your list, we find zinc and we find hydrogen. So if the element by itself is higher, the reaction will occur. So will this reaction occur? Yes. For single replacement reactions, we're going to use this chart. So according to the activity series, will this reaction occur? Yes, and I said it will occur. So that means that zinc is going to replace hydrogen. So some things that we need to know to do this. I need to know that zinc is always a +2. Chlorine's always a -1. And so whenever I write my reaction, it's going to be zinc chloride, but ZnCl2. Now, since zinc replaced hydrogen, what happens to hydrogen? Since zinc replaced hydrogen, what happens to hydrogen? It's going to be by itself. And how do I write hydrogen when it's by itself? Come on, computer. So again, let's do this and let's kind of look at some more practice. So I'm leaving my activity series up there. So just again, kind of reinforcement on this. If the lone element is more reactive than the element it would replace, then the reaction will occur, and we call that a spontaneous reaction. Spontaneous means it happens on its own. All right, we don't have to add any energy. We don't have to add anything to it. Yes? You might, or electricity or something to call. If you want it to happen, you're going to have to force it to happen. All right, but it will not happen by itself. All right, so if the element is less reactive, if it's lower on the list than the element it's trying to replace, it is called non-spontaneous. It does not occur. All right. So going back to the example I already kind of showed, and we already decided this reaction will occur. And the reason why is because zinc is higher on the list than hydrogen, so that reaction will occur. So zinc will push hydrogen out. Hydrogen's now going to be the element by itself. Sorry, I'll go back to it. All right. So, how do we know? Again, how do we know if we're looking at a single replacement reaction? How do we know if one reaction is more, if one element is more reactive than another? Where do we look? We look at the activity series. So we're going to look at this list. And again, I will get you a copy of this list for the reference packet, but just want to make sure it's there. So this table doesn't just give us the activity of metals, it also gives us some for nonmetals. So notice they have some nonmetals listed for reactivity, but what are the only nonmetals that they list? Where are they located? They're all halogens. They're all group 7A ones. So fluorine's going to be the most reactive. Iodine's going to be the least reactive of those. So we'll only ever have to replace fluorine, chlorine, bromine, or iodine in these types. All right. Notice on the metal side that silver and gold, well, really copper, silver, and gold are the least reactive metals. So I don't know if it has anything to do with it, but they're also three of the most conductive metals that we know of. But that's also why copper is great in industrial purposes, like for wiring and things like that, because not a lot of stuff will break down copper. Copper, when it oxidizes, it makes a coating over it. It doesn't rust. It doesn't deteriorate like iron or tin or anything like that else would. And gold and silver just is too expensive to run wires with, because but if you have high-end stereo stuff, if you have computer components and all that, they'll use gold in those because they are very conductive and there's not a lot of heat loss in there. All right. So now, what if the reaction does not occur? If something in the compound is higher than the element by itself, we simply write no reaction, that no reaction has occurred. So, and there's no need to balance it then. So let's look at this example. Why am I telling you that there's no reaction between magnesium and lithium nitrate? So when I look, here's magnesium, here's lithium. Lithium's already in compound. Magnesium is not. So if I took some lithium nitrate and I dropped a hunk of magnesium in it, the magnesium is just going to stay what it is. All right, it's not going to react. It's not going to bubble. There's just going to be a piece of magnesium that would sink down or float to the top, depending on density. All right. So if the element in the compound is higher on the list, then the reaction doesn't occur. If the element by itself is higher on the list, then the reaction will occur. All right. Well, you know that one already. But I want you to go ahead, write this one down, predict if it'll occur. Let me see if I can fix this real quick. All right, so let's look at these real quick. All right, so the first one, magnesium with zinc nitrate. Will magnesium replace zinc nitrate? Yes. So magnesium is higher than zinc. So that means that we're going to get magnesium nitrate and zinc. Remember, we have to crisscross the charge, so it's going to be Mg, open parentheses, NO3, close parentheses with a 2, and then zinc by itself. All right. What about magnesium with silver? Magnesium is much higher than silver, so that one will happen. So we end up with this. We would have to balance it. So I need 2 of those, and ultimately I'm going to need 2 silvers, but my box for the 2 doesn't pop up right away. What about chlorine reacting with sodium bromide? Is chlorine higher than bromine? So chlorine is higher than bromine on the list, so it becomes NaCl plus bromine. And then what about, and then the last one should have been no reaction because tin is lower than sodium on the list. And then balancing all of them, you should have gotten this. Yes?
So if it's I think you said it, but if it's a non-metal, it's got to switch with a non-metal?
Yes, because an anion has to replace an anion. So a negative ion has to replace a negative ion. All right.
So this one you don't have to worry about balancing it, right?
Well, you do ultimately balance. I went back and balanced all of them. I just didn't. If the reaction happens, you have to balance it. If there's no reaction, then there's nothing to balance. All right. So all right. So let's look at this sheet for practice. Yes. The Roman numeral 2 next to copper tells us that copper is a +2 charge. You don't write it in your chemical formula. You know that it tells you copper is a +2 charge, and that allows it to react with sulfate, which is the -2 charge, as a 1-to-1 relationship. All right. So let's look at this. All right. All right. So right now, I want you to go ahead and try number 1, number 2, number 5, and number 8. 1, 2, 5, and 8. Yeah.
We've got to balance it, right? Oh, just get two of them. No, because CO. CO is a two. We write a two by CO. I'm pretty sure, like all nine. And then also, whenever you rewrite it, it should be that very also.
Or would it be this? Or would it be this? It would be the bromine and the.
It's like
Yeah.
All right. All right. So has everybody had a chance for number one? All right. So magnesium bromide, your formula should have been MgBr2 plus Cl2. Does everybody agree with that at that point? Will this reaction occur? Yes. So the reason why is because chlorine is higher than bromine. The element by itself is higher than the one above it. So that means we get magnesium chloride and then bromine by itself. All right. Don't have to do anything to balance this one. Why? Can somebody tell me why it takes two bromines to react with magnesium? Because of the charge. Magnesium's a +2 charge. Chlorine and bromine are both -1s. So it's going to take two of them to offset it. All right, looking at number 2, we have aluminum plus iron 3 oxide. So that means this one is going to be Fe2O3. Is everybody with me of why I wrote Fe2O3? Oxygen always has a 2 charge. Iron has a 3 charge in this one, so I have to flip and drop them down. Will that reaction occur? So I'm looking at aluminum and I'm looking at iron. Aluminum's by itself, it's higher. So now that means it's going to react with oxygen. So aluminum makes a +3, oxygen's a -2, so it's Al2O3 plus. All right. Now to balance it, I need 2 irons on the other side. I need 2 aluminum, so I'm going to put a 2 there, and I'll put a 2 there. All right. What about, so zinc plus hydrochloric acid. So I can look up hydrochloric acid in my reference packet and know that hydrochloric acid is HCl. So we already talked about this one. We know this one's going to occur because we've done it multiple times. So I have zinc and hydrogen. So zinc is always a +2 charge. So it's going to be ZnCl2. And then hydrogen is a diatomic molecule, so it's always H2. So to balance it, I put a 2 in front of HCl, and it balances.
Wait,
Yes?
how do you know that zinc is always supposed to, like, how do you know what the
Because my periodic reference table, if I look at the box that says select transition metals, and I find zinc on there, it tells me that zinc only ever has a +2 charge.
It's like the ones that have like two, how do you know
They have more than one, so you'll have to use Roman numerals on those. But if they only have one charge by it in that box.
wait, what do you mean that? The one that you don't use, you have to use the
All right. So in your periodic table reference packet, wrong packet, find the box that says select transition metals.
I got it.
All right. If you look by zinc, what charge does zinc have?
2 plus.
+2. What charge does silver have? Ag. +1. All right. What about gold? Au. So a +1 and a +3. So that means I have 2 variations for gold. For iron, I have 2 variations. For manganese, I have 4 different opportunities for different charges. So those I have to use Roman numerals for. The ones that only have 1 charge, I don't ever have to write Roman numeral whenever I'm writing the name.
Oh, okay.
All right, now acetic acid. I'm going to pull that up over here. So it's HC2, H3, O, O2. I don't always remember that one. O2. All right. Now, I'm reacting that with copper. Will this reaction occur? All right. So in this one, I'm comparing, and I'm just drawing the box for clarity. I'm comparing copper with hydrogen. So I'm comparing this hydrogen with copper. Copper is below hydrogen, so we would say no reaction. All right. Questions? All right. So all right, continue working in chapter 7 of active. You should be able to do all of these problems. There are a few more I think that I had assigned. If you check back to yesterday's post, I have all of them that you can do assigned. There is going to be some things for prediction, but we need to know a couple of more things to be able to predict the rest of it. So I'm going to do that tomorrow. Now, as you're going through this, be careful. I recommend writing the stuff down and not trying to balance them in the computer, because you'll make simple mistakes when you're balancing a computer. It's easier when you can see it on paper and you can erase and all of that. So just be careful with all of that. The other thing that I'm going to say. All right. So some of you have not been keeping up with active. Some of you have been doing a great job. You have all like 90s and above for your actives.
Yeah.
Some people, all right, some of you have not kept up with some of them. I am not going to change my gradebook scores on this, but in order to help you get a higher average for your homeworks for Southeastern, I'm going to reopen those old ones that if you had not finished it before it closed, you'll have the opportunity to finish those and get a higher score. I'm not going back and resetting questions or anything like that. I'm just going back and reopen it so that if one of them closed out for you and you ended up with a 60 on it or a 63 or a 40 or whatever because you just didn't do it, I'm going to reopen them. I'll leave them open until we take test 2. The follow-up, that just appears sometimes after you complete a assignment. I forget to turn it off because it makes things messy on my end. But no, you do not have to do the follow-up. I am going to reopen chapters 1 through 6. I will not change your Power School score on it. Because that was a due date. It was done. We're past that. All right. But it will change your average for Southeastern if you're still trying to get that higher average on your homework. All right, which will end up helping you.